The choice.
Yes, sir.
Show me the choice. Kunjani lapho.
It's fine, sir.
Are you able to clearly see over there?
Yes, sir.
Okay, 100%. So I just wanted to check, Chumi. Have you done trigonometric functions in class? Have you started with those?
Yes, sir.
Are you confident with these functions?
Not really, sir.
Not really, nay. Okay, it's fine. So I want you to be aware of something, Chumi. Trigonometric functions are actually the functions of the trig functions. What are the trig functions? Or what three trigonometric functions do you know, the Chumis?
Isn't it sine, cos, and tan?
Yes. So we only sketch the functions of sine, cos, and tan. So when we talk about a function, Chumi, we simply refer to y in correspondence with x. So we actually want to know what is the y value as the x value changes, or otherwise, as the x value changes, what is the y value. But in this case, we'll be sketching the functions of, for example, y is equals to sine x, x being the angle, or otherwise y is equals to cos of angle, otherwise y is equals to tan angle. So these are the angles, the functions that we'll be sketching, Chumi. Sometimes they also give you a restriction to say, sketch these functions for where x is the element of 360 degrees and negative and 360 degrees. So this thing, Chumi, it actually tells you in terms of where to start and where to end when you sketch your function, which could be the function of sine, cos, or tan. Where do we draw functions, the Chumis? We draw functions on a Cartesian plane. This is a Cartesian plane, Chumi. It has the y and the x axis. So there's something called the period. I'm not sure if you remember something about the period, Chumi.
Isn't the period where it's in the middle of the Cartesian plane?
Okay, so the period of a function is the value in which the function repeats itself. I think I'll have to explain this one as we continue. For example, Chumi, let's say a function of sine, or otherwise, let me just try and make it simple to say, if we have, for example, interval of 1, 2, 3, let's say 4, 5, 6, 7, 8, 9. I'm going to draw or to write something here, Chumi. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to draw something here, Chumi. You tell me, what is this thing? It's either I've drawn it or I've written it. What is this thing, Chumi? What is that letter?
Is it not the letter M?
Yes, it's letter M. So when we talk about the period, it's more like we want to know how many angles or how many values are needed for M to complete its shape?
Yes, sir.
So the question is, how many values do we need for M to complete its shape?
Isn't it 3 values, sir?
Yes. So that means the period for M, or for letter M, the period is equals to 3. Maybe let's say 3 degrees, because in this chapter we talk about angles which are measured in degrees. So if I draw that again, how many units there, Chumi, does that letter need to complete? Still 3, isn't it?
Yes, sir.
Yes. So that's what we mean by the period. We want to know, when M is complete in terms of the shape, how many angles does it need? Can you see there a future? No, Chumi. So the period for the sine function, it's equals to 360 degrees. So for example, if maybe when we sketch the function of sine, it goes like that. This is how it looks like when it's complete, and it needs from 90, 180, 270, 360 for it to complete. I'm not sure if you understand what I'm trying to explain there regarding the period, Chumi.
I do understand, sir.
Yeah, so the period for the sine function is 360. Also, for this one, of course, is 360. You might find that maybe for cos it starts going down and then it goes up and then it does that. Then it's complete. So if, for example, it goes to this side, it also needs 360 on the negative side to complete. Same for sine, it also needs 360 to complete. So you have that shape which is completed after 360 degrees. You also have that on that side which is completed after 360 degrees. Does it make sense there, Chumi?
Yes, sir.
Okay. The period for tan. Do you remember that one? Did they tell you about that one?
No, sir.
Okay. So for tan is 180 degrees. Nay. So that
Yes, sir.
means the function of tan repeat itself, or it forms the shape, the same shape after 180 degrees. So let's maybe not complicate it and try to sketch the first function. So let's say we have a Cartesian plane, and on the Cartesian plane, let's say we have a y and x. Then we have there 90, 180, 270, and 360. Negative 90, negative 180, negative 270, negative 360. You remember, Muschumi, with regards to a circle, this is 0, 90, 180, 270, 360. But on a Cartesian plane, when we draw the functions, we represent them along that x-axis. Meaning here we have 90, we have 180 there, we have 270 there, we have 360 there. Then here, what we have there, we have negative 90, negative 180, negative what? Negative 270, negative 360 degrees. Then here we can maybe have negative 1, and then there we have positive 1. Do you understand that part, Chumi, in terms of setting up that for you to start sketching the function? Do you understand that part, Chumi?
Yes, sir.
Okay, maybe let me try to make you think of something. Why did I have negative 60 there up to 360 there? Why did I not maybe sketch this side only? What is the reason for that?
I'm not sure, sir.
Okay, so this is what guides you in terms of where to start and where to end. Can you see there, Chumi?
Yes, sir.
Yeah, so if maybe they said x is the element of, let's say, a negative 180 degrees and a positive 180 degrees. So that means when you sketch, you don't show that part and you also don't show that part because they say start from negative 180 in that direction and end as at positive 180. Can you see there, Chumi?
Yes, sir.
Okay, so let's sketch this function. Let's sketch the function of y as equals to a sine x. Sometimes they give these functions name. Maybe they can say f of x. So when they say f of x is the same as y is equals to sine of x. So f of x and y, it could be g of x, h of x, or whatever, is the same as y being equals to whatever they. So I'm not sure, Chumi, if you still remember how to sketch these functions. Just let me know if you forgot so that I can train you on how to sketch the functions.
Yes, I did forget how to sketch those functions, sir.
Okay, so this is what you do. Agree sketching for sine is equals to x. So that means at x, we are going to change the angles. So on your calculator, Chumi, punch sine of. Then we'll start with the first angle. Then I'll show you how to work it out. Let me know once you're done with the sketch. I mean, with punching that on a calculator.
I'm done, sir.
Okay, we start from negative towards the positive. So, um, punch sine of negative 360. What are you getting?
0.
Then you make a dot where y is 0 and x is negative 36. Or otherwise, maybe let me do this, Chumi. I'm just not sure if you understand it. So remember, we have x and we want to plot the y values. So x there you can see is negative 360, and then here negative 270, and then negative 180, and then negative 90, and then x there is 0, positive 90, positive 180, and then positive 270, and then positive 360. So you say when you punch on sine of angle, when you punch negative that, you say you get 0. So you make a dot there where x is 0 and where x is 360, y is 0. What about negative 270 there, Jim? What are you getting there?
1. Positive 1.
So you make a dot. You tell me, where do I make a dot, Chumi?
Um,
Where x is negative 270 is there and y is positive 1. So you make a dot where that and that join. Can you see there, Chumi?
yes, sir.
Okay, punch the next one. Negative 180.
I'm getting 0, sir.
So you're getting 0. That means this is where I'm going to make a dot. Can you see? Does it make sense now that you miss?
Yes, sir.
Okay, next one.
Negative 90. I'm getting negative 1.
Where do I make a dot?
Um, at the y-axis at negative 1.
Here.
Yes, sir. Below negative 90 degrees, where
Yes,
negative 1 is going to be 90.
below negative 90 along negative 1. Yes. And then the next one.
I'm getting positive 1. So above 90 by
What
1.
what what did you punch there as an
Sine
angle?
of positive as an angle. I said sine
For
of positive 90.
Oh no. You skipped 0, the chumi. So 0 is also an angle there.
Oh,
Yes.
oh. Sine of 0, I'm getting 0.
Then you make a dot there at that intersection, because that's where x is 0, y is 0. Next one, you said you got 1. This is where you make a dot. What about the next one?
I'm getting 0, sir.
Yes. Where do I make a 0?
On the positive 180 on the x-axis.
Yes, you make a dot there. And then the next one?
I'm getting negative 1, so it's below 270 and across
Yes.
from negative 1.
Yes, there. And then the last one?
I'm getting 0.
You get 0. So that's how you plot it. Then you just connect these lines that you miss. You just connect these lines. Can you see there the chimneys? Can you see it has completed its shape? So we are going to start from 0 to plot on the positive side. You will see it's going to make the same shape. Let me do it as dotted line so that you can see that it actually does the same shape. Can you see, Chimi? It does that and that U, the upside U and the upside U. Can you see? So that is why we say from there to there, it's actually 360 degrees, which is the period of that function. And also from there to there, it is 360 degrees, which is the period of that function, for it to repeat its shape. Can you see there, Chumi? I'm not sure if it makes sense
Yes,
now,
sir.
the Chumis.
Yes, it does make sense, sir.
Okay, so now this is the one that you're going to sketch, the Chumis. I'll give you a chance to sketch this one. I'll just be with you. Sketch this one, Chumi. You'll just be explaining to me in terms of how you'll be doing it. Sketch this one where x is the element of negative 360 degrees and positive 360 degrees. Sketch that one that you miss. So how you're going to do it, as you're writing on your side, you'll just be explaining in terms of what are you doing there. Then if you have questions, you can ask me.
Okay, sir. So first, I'm going to draw the Cartesian plane.
Mm-hmm.
And then I'm going to put in the numbers
Sure. You're breaking the Chumis. I'm not sure
90.
what could be the issue there. I can hear you speaking, but it's breaking, the Chumis. Can you hear me?
80, 270, then 360, then negative 90, negative 180, negative 270, negative 360 on the x-axis. Then on the y-axis, I'm going to put 1 and negative 1. Then I'm going to say cos of negative 360, I'm getting positive 1. So it's going to be above negative 360 and across from negative 1. Then I'm going to say negative 270. Yes, I can hear you, sir.
Chumi. Chumi? So let me do this, because you know the other phone was hot, so let me just leave. Can you hear me now, Chumi? Are you still there? Chumi, can you hear me?
Yes, sir.
Yes, sir. Okay, so the other phone, the temperature was hot. So let me see. I've just connected with this other one. Okay, so you were still explaining there. How far are you? And also, there was a time where the network was a bit poor. So you can now maybe continue the tunes. What were you saying then?
I was saying, sir, so at negative 360, when you say, I'm going to say cos of negative 360, and I got positive 1. So the dot is going to be above negative 360 across from positive 1.
So you're saying there, this is where you're going to make a dot.
Yes, sir.
Okay. Okay.
Then I punched in cos of negative 270, and I got 0.
You got 0.
So the dot is going to be on negative 270. Then I punched in cos of negative 180, and I got negative 1. So it's going to be below negative 180 across from negative 1. Then I punched in negative 90, parts of negative 90. And I got 0. Then I said cos of 0 and I got positive 1.
You got positive 1.
Yes, sir. Then I said cos of positive 90 and I got 0. Then cos of 180, I got negative 1.
Cos of 180, you're getting it. Okay.
Then cos of 270, I got 0. Then cos of positive 360, I got positive 1.
Cos of 200 and... Hey, cos of what did you miss?
Cos of positive 360.
Oh, yes. You're getting that, ne?
Yes, sir.
Okay. So, can you see, Chum, it's just a matter of you connecting the dots. You connecting the dots. Connecting the dots. Can you see, Chumi? From that point, can you see it does that shape of a U and then it ends there? And from there to there is 360. And again, from there to there, it makes the same shape. That is why we say the period of this one is also 360. So that means the period of a sine and cos function is 360 degrees, because after every 360 it repeats its shape. Does it make sense there, the Chumis?
Yes, sir.
Okay, so now let me um let me sketch. But are you happy with sketching those two? How to sketch those two there, the Chumis?
Yes, sir.
Okay, so now let me show you how you sketch that one of tan. So it could be a g of x, which is equals to a tan x, where x is the element of negative 360 degrees and positive 360 degrees. So you still do the same. Because of this, then it means you must start at negative 360, there is 90, there is 180, there is that, 90, that, and that, x and y. So this is negative 360, negative 270, negative 180, negative 90 there. Then positive 90, positive 180, positive 270, positive 360 there. So a punch that one, the chimney, start with that angle. What are you getting there?
Could you please repeat your question, sir? I didn't hear you.
Okay, so I was saying let's start to plot this one. Start from negative 360. What are you getting there when you punch?
When I punch in tan of negative 360, I'm getting 0.
Okay, next value.
tan of
tan of
negative
negative
270 is
270 is
math error.
error.
I can't get the
I can't
tan
get the
of
tan of
negative
negative
270.
270.
Oh, it gives you an error, ne?
Yes, sir.
Yes, sir.
Okay. Where it gives you an error, you do the dotted line. So this is the asymptotes. These lines, we call them asymptotes, the dotted line. Can you see there the tuning?
Yes, sir.
Yes, sir.
Okay. What about the next value? What are you getting there?
I'm
I'm
getting
getting
0
0
for
for
tan
tan
of
of
negative
negative
180.
180.
Okay, we have 0. The next one?
Tan
Tan
of
of
negative
negative
90,
90.
it's an
It's an
error.
error.
Then what do we do if it's an error?
You draw
You
the
draw the
dotted
dotted
line.
line.
Yeah, it's called equation of asymptote. This is an asymptote. Just remember that. Asymptote. Okay, there you go. So what about the next value there?
Tan of
Tan
0
of
is
0
0.
is 0.
Okay, next value.
Tan of
Tan of
90 is
90
an
is
error.
an error.
So we're going to
So we're
use the
going to
line
use
of
the line of
asymptote.
asymptote.
Next value.
Tan of
Tan of
180 is
180
0.
is 0.
Okay. We have 0 there.
Tan of
Tan of
270 is a math
270
error.
is a math error.
So we're going to do
So we're
the
going to do
line
the
of
line
asymptote.
of asymptote.
Okay. Next value.
The tan
The
of
tan of
360 is
360
0.
is 0.
Is 0. Okay. So can you see there the image? There's something about this function of tan. It has asymptotes and at this angles is just 0, 0, 0. So we might need to know the values in between so that we can know in which direction this function is going to go. I'm not sure if you know what is the value between 0 and 90. Do you know the Chumis?
Isn't it 45, sir?
Isn't it 45, sir?
100%. It's 45. So that means from 45 you go to 90. 90 at 45 it takes you there. Plus 45, 18. Plus 45, that. Plus 45. So you just add by 45 to get all the values there. Also here on this side, it's going to be the same values on that side, but with the negative values. Does it make sense there, the humans?
Yes, sir.
Yes, sir.
Okay. So now that we have 45, 90, what is the value there? Let's check. So if we have 45 plus 45 is 90, plus 45 is 135. Do you agree there, the Chumis? So you just say plus 45 is 180, plus 45 is 225. Do you agree there, the Chumis?
Yes,
Yes,
sir.
Plus 45, 270, plus 45, 315. Can you see there, Chumi?
Yes, sir.
Yes, sir.
Yeah, so that means you're going to have the same values but with the
Yes, sir.
negative values. The
Yes,
negative
sir.
45,
Yes, sir.
negative 135, negative 225, negative 315. So what you need to do, Chumi, you still need to punch these values in between on your turn so that you know where is a point along the y-axis. Remember there is 1, maybe there is negative 1. Okay. Can you see there, Chumi?
Yes, sir.
Yes, sir.
Okay. So, what do you get when you punch tan negative 315?
The tan of
The
negative
tan of
315
negative 315
is positive 1.
is positive 1.
It's positive 1. Then you put a dot there, which means this function there, it goes like that. It never touch or cross asymptote. What about the next value? Is this one correct?
The
Because
tan
we
of
know for
negative
270, what about the
225
The tan of negative 225
is negative 1.
is negative 1.
yes, you put a dot there. What about the other value?
The tan of
The tan
negative
of
135
negative 135
is positive 1.
is positive 1.
Yes, it's positive 1. You put it at there. Then you just connect. It goes like that. And then you also connect this one. It goes like that. Can you see there the achievement? Then you do the same there.
Yes,
What
sir.
about
Yes,
there?
sir.
What are we getting there?
The
The
tan of
tan of
negative
negative
45
45
is
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 negative 1.
negative 1.
Yes. So it's going to take this same shape. So you're going to have negative 1 there. You have a 0 there. At 45, it's going to be 1. Then it's going to do that same shape there when you connect the dots. Also here, the chum is going to be negative 1 there, positive 1 there. Then we just connect the dots. So you just connect the dots. Can you see there the chum is? And this one there is going to be negative 1, and then it does that. Can you see there, chum?
Yes, sir.
Yes, sir.
Yes. I think now you do remember. Okay, before I remove all of that, can you see why we say the period for this one of tan is 360? Can you see between that and that, it has completed its shape. Between that and that, it has completed its shape. Also there, between that and that, it has completed as the shape. And between this negative that and that, in between is 180. From there to there, it's 90 and 90 is 180 degrees. From 90 to 270, the space in between is 180. So that is why we say the period for the tan function is 180. Do you now understand what I meant by the period being 180 and also for 360 there? Does it make sense now, the Jumi?
Yes, sir.
Yes, sir.
Okay, so this is what I'm going to do, Chuni. I'm going to give you some problems to work on, and then once you are done, you send them via inbox. And then in case if you get them wrong, we'll still do another lesson where I take you through the corrections. But if you get it correctly, then that would mean you did understand. And then on our next lesson, I will need to start preparing, compiling some question papers, of which I will then send to you via inbox, and then you will start practicing. Then we'll start doing some corrections on those, or we'll start tackling some exam question paper. So here the tune is, let's say we have 1, and then here now is 2. Let's say sine of x, and then sketch this one on where x is the element of negative 270 degrees and 270 degrees. This is number one to me. Let's say number two, sketch the function of y is equals to, let's say, half of cos angle, where x is the element of a negative 360 degrees and positive 90 degrees. Then number three, let's say we have tan of, start with y is equals to a tan, let me do that and say 2 tan x, yes, where x is the element of negative 180 degrees and 180 degrees. This is something they might give you in exam tuning. Do you not have any questions before you start working those? So what I'm going to do now, the tumis, I've recorded this lesson, so I'll end it now. But at the same time, it's either you decide to do it now or you take some break or you'll do it at a later stage. Then from there, once you are done, even if you send tomorrow, it's still fine. Whenever you get chance, you can do it. Once you're done, then I'll look at those, mark, and check where you made a mistake. Then I'll take you through corrections if you got them wrong. Otherwise, if you get them correct, then it means we'll be moving to exam questions. Did you copy all of those, the tunis?
Yes, sir.
Yes, sir.
Okay, so do you think you can be able to then work on them when you get a chance?
Yes, sir.
Yes, sir.
Any questions?
No, I don't have questions,
No,
sir.
I don't have questions, sir.
Are you sure you'll be able to sketch all of these, the tunis?
Yes, sir.
Yes, sir.
Are you sure, the tunis? No questions.
No questions, sir.
No questions, sir.
Okay. Then in that case, it's fine. I'll end this lesson, then I'll wait for you once you are done.
Okay, sir.
Okay, sir.
Okay, all right. Sharp the tunis.
Bye, sir.
Bye, sir.